Today's goal is to solve a right triangle. And we're going to dive into what this means. What does it mean to solve a right triangle, and how do you do it? And rather than random examples, we're going to jump right into your assignment. Question 1, the directions say solve this triangle. Round answers to the nearest tenth. Okay, well first thing I want you to realize, when you solve a triangle, you need to find 6 answers. Okay, and in capital letters, here we have the capital letters A, B, C. The capital letters are going to represent the angles, the 3 angles of the triangle. And actually, let me write it like this. Let me write this in caps. In capital letters, these are the measures of the 3 angles of the triangles. These are all going to be in degrees. And right off the bat, we already know 2 of these answers. You can see that angle C here is a 90-degree angle. Yes, it's that easy. For angle C, we're going to select 90 degrees. Angle B here, capital B, it's given in the diagram that it's 63 degrees. Well, yeah, there we go. That's the answer. 2 of these answers were given to you. Okay? And then if you remember anything about triangles from geometry class, it's going to be really easy to find this angle A. You know, the 90-degree angle plus the 63-degree angle plus angle A. The 3 angles of a triangle always add up to 180 degrees. So just using a little bit of basic math here, a little bit of basic algebra, I should say, angle A is just going to be 180 degrees minus 153 degrees, which comes out to 27 degrees. Okay, so right off the bat, boom, there's how we find, if we're given 2 of the angles, there's how we find the 3rd missing angle of the triangle. Okay, now these lowercase letters down here, these represents the 3 sides of the triangle. And I'm going to write sides in lowercase letters. Here I need to find side A, the length of side A, the length of side B, and the length of side C. Now the sides always go opposite of its corresponding angle. Okay, so since my angle A is right here, then I'm going to go all the way across from that angle. The side farthest away from angle A is actually called side little a, lowercase a. Likewise, my angle B is right here, so I travel as far away as I can from that. That means this side that's 14 units long, it's going to be side little b. And then my angle C is right here, the 90-degree angles. That means my hypotenuse is going to be little c. Okay, so I'm given one of these. Side B is 14 units long, but I do not know side A nor side C. That's what I'm going to find. All right, so how do we do this? Well, the answer is I'm going to do it one at a time. What I like to actually say is this. I like to actually take like a little, I'm going to take just a little post-it here that I cut off. And between side A, I need to find side A and side C, but I can't find them both at once. I can only find them one at a time. So I'm going to say that I want to find side A first, and guess what? I'm just going to cover up side C. I'm going to cover it up, pretend like it's not even there. Okay? So if I label here that C is my hypotenuse, and I have this 63, I'm going to use 63 degrees as my featured angle. So that would make 14 my opposite. And that would make this side A my adjacent. Well, if I cover up side C, that's just like crossing off the hypotenuse. And so I look at what I'm left with. I'm not worried about C right now. I don't care what it is right now. That leaves me with adjacent and opposite. This is going to be a tangent problem. In order to find side A, I'm going to use tangent. Let's write out the formula here. Tangent is opposite over adjacent. So I decided to use 63 degrees as my featured angle. That's going to be theta. Okay, theta is 63. That's the decision I made right off the bat. Opposite is 14. I know its length. Adjacent is not known. The adjacent leg I'm marking here with an A. And remember, since my variable is on the bottom of this fraction, I'm just going to do the flipperoo here. This missing side A is just going to be 14 divided by the tangent of 63. 14 divided by tangent of 63. And please do make sure that your calculator is in degree mode for this, especially if you have a graphing calculator. You want to be very careful of that. But to the nearest tenth, this is going to be 7.1. Approximately 7.1. Okay. Now I do want to caution you here. Technically, to find side C now, you could technically use Pythagorean theorem and take a squared plus b squared equals c squared. I would not recommend doing that here though, because remember, side A, this is a rounded answer. In reality, this should be an irrational number, but we had to round it to 7.1. And since this is a rounded answer, that's always going to cause some type of error if I was using Pythagorean theorem to find C. My advice instead is now, if I'm trying to find C, now I'm going to cover up the A. I'm going to pretend like the A doesn't exist. And that's going to leave me with just my opposite and my hypotenuse. This is a sine problem. Let me write out the formula for sine. So theta is my angle 63. And opposite, looking back at this problem, opposite is the 14. Hypotenuse is the variable C. And we've gotten a lot of these where the variable's on the bottom. Remember, if the variable's on the bottom of your fraction, we're going to flip these around. 14 divided by the sine of 63. Get out my calculator. 14 divided by the sine of 63. That comes out to the nearest tenth to 15.7. So C is approximately, to the nearest tenth, 15.7. Okay, so this is how we solve a triangle if we are given one of the angles and one of the sides. And let's end this video by jumping to the very last question. Question 4, solve this triangle. Round sides to the nearest tenth and angles to the nearest whole. Well, let's look at the information that we do have in this problem. So look at my angles. I do not know angle A. I do not know angle B, but I do know angle C, 90 degrees. Okay. Now let me look at my sides. So side A would be over here. That is unknown. Side B would be opposite of angle B. That would be up here. That would be the 6.8. And side C, that would be opposite of angle C. It's also the hypotenuse. That would be 15. So look, even if you learn nothing else in this whole video, well, you already have half of the answers, okay? The problem gives you half of the answers. You're going to score at least a 50% on this assignment at the worst because you already know half the answers, okay? Now we don't want to settle for that. Let's find the rest of the answers. So I am going to, let's start now on how we can find these angles, angles A and angles B. Well, if you look at, here's what you have to do. I need to find both of these angles, but again, right off the bat, I'm going to pretend, if I need to find angle A, I'm going to kind of pretend like angle B doesn't even exist. I'm going to cover it up. So here I'm making A my reference angle. I'm making A my theta. I can even put a little theta sign in there if I want to. And let's label, if angle A is my featured angle. If angle A is my featured angle, that would make side A opposite. That would make side B would be my adjacent. And then this length here, this longest length, of course, is the hypotenuse. Okay, so I know that the hypotenuse is 15. I know that the adjacent leg is 6.8. I'm going to cover up this hypotenuse. I can find angle A by using a cosine problem. Here's the formula for cosine. Cosine of theta is adjacent over hypotenuse. So cosine of theta is going to be 6.8 over 15. And remember, to find a missing angle, this is where I use what's called inverse cosine. If I take the inverse cosine of this fraction, this will tell me the value of angle theta. So instead of hitting the cosine button, I'm going to hit second cosine to get my inverse cosine on my calculator. 6.8 divided by 15. That comes out to now, the 63.0 degrees. The directions actually say around the angle to the nearest whole. we're just going to say 63 degrees. That's how we're going to answer it. Okay, so a whole number, do not include the degree sign. Just write 63 in that blank, please. And then, so to solve for angle B, now we can just use our rule of 180. These three numbers need to add up to 180 degrees. So 63 plus angle B plus 90. What did I say? I think I said that wrong. These three angles have to add up to 180 degrees. I can't remember if that's what I said or not. But using a little bit of algebra here, you find that our missing angle B is going to be 27 degrees. Okay, so that's a 27. And then, so to find side A, you have a few options, but honestly, if you're ever given two of the sides and you need to find this missing side A, I would tell you this, just use Pythagorean theorem. You know A squared plus B squared equals C squared. So A squared plus 6.8 squared is equal to 15 squared. We can find this pretty simply in our calculator. 6.8 squared is 46.24. I'm going to write all of that out. I don't want any round off error, so I'm writing out all of that. So I'm going to subtract that from 15 squared, which is 225. Get the calculator out. 46.24. That comes out to 178.76. And luckily for us, the directions say we can just round this to the nearest tenth. That would be really hard to simplify this as a radical. Here, though, we just get to round. The square root of 178.76 is approximately 13.37. Now read the directions carefully. The directions say round to the nearest tenth. So we're going to write 13.4 to the nearest tenth. Okay. So with this particular example, this is how you solve a right triangle if you're giving two of its sides and neither of its acute angles. This is how you would do it. All right, so question 3 is going to be very similar to question 4, whereas question 2 is going to be more similar to question 1. All right, best of luck on this. Bye.